Hello, this is Mr. Henry, and welcome to Lesson 5.1, Introduction to Functions. The central question says, how do I determine if a given relation is a function? And for our warm-up today, we've got a Collins Type 1 writing. So take 2 minutes. Begin. The question says, write 2 questions you have about functions. I'm going to pause the video. You take your 2 minutes. When you're ready to continue, hit play, and we'll go through it together. All right, so you might have wrote some things in there like maybe what is a function, what does it do, what does it look like, how is it useful for us. There's a variety of questions you could have put in there. So your job was just in that 2 minutes to write 2 questions. So let's get started into this new module. So you have a whole bunch of vocabulary words here. First one is a relation. So relation is a set of ordered pairs. Relations can be shown using tables, lists, or graphs. This relation is another way to say it's a function. Okay, so from this relation, you will always have your input, which is the x-coordinate of that relation, and your output, which is the y-coordinate of that relation. So the x value you plug into this relation. The relation is, I say, some relation between the input and the output. It does something in the middle, and that gives you your output. A function is a relation in which each input has exactly one output, and then this vertical line test. The vertical line test is a way to test if a graph is a function. Use to determine if a graph of a relation is a function. Now, some of these may not make much sense to you right now, but as we're going through our examples here throughout the lesson, they'll become more clear on what we mean by the relation or a function, inputs and outputs. We're going to use all of these terms quite a bit throughout this entire Module 5, since this entire module is devoted to functions, linear functions, nonlinear functions. What is a function? What isn't a function? How to make functions, how to graph functions. I mean, everything that has to do with functions and inputs and outputs. In some other words, we'll talk about domain and range and relations, vertical line test, okay? So if it's not quite clear yet, it's fine. Let's get into the lesson and make it more clear. So here what you see is the directions asked us to determine if each relation represents a function. Okay, so for letter A here, we have ourselves a table. So we have inputs, we have outputs. Now, the way that I like to think of functions when you're talking about something like a table is like I like to imagine a soda machine. So if you imagine a soda machine, a working soda machine, every time you hit the same button on the soda machine, you get the same soda back out of it. So if there's a button that says Coke on it, every time you hit that Coke button, the machine spits out a Coke. If you have a machine that says, or a button that says like Dr. Pepper, and a button that says Mountain Dew, every time you hit that particular button, you know what to expect back out of it. So in terms of a function as a table, it's the same idea. Every time I plug in the number -5, I should get the exact same answer, -3. So I look through. I don't have any other -5s. All right, that's fine. So this machine only has one button for -5, only has one input of -5, and it's always giving me the exact same output. So look at 0. Every time you put a 0 into the function, it should give you -2. And it does. Every time you put a 5 into the function, it gives you -1. It works. 6 gives you 5. -3 gives you 7. This is a function because, and this was something we had in our definition of a function, because each input has exactly one output. So the number -5 only had one output. It didn't go to like a -5 comma like a 4. This, if you throw this bottom line on here, it would make this not a function, because now -5 goes to -3 and -5 goes to 4. That'd almost be like you in your soda machine. If you hit Coke, like you're hitting the same button, the same input, you hit a Coke, and one time it spits you out a Coke, and another time it spits you out some other soda that's not a Coke. Maybe it's like Sprite or something like that, and you're ticked off because it's not the thing you wanted. Well, that's what this is. If we have this input with 1, 2 different outputs, that would not be a function. Okay? But the way the problem starts, this is a function. So is this a function? Yes, it is a function because each input has one output. All right. Letter B. Now we're talking about a function that's represented as a graph. Now, in our vocabulary box, we had something called the vertical line test. So here is a very thick, we need to thin that up a little bit. Here is a vertical line, this red line. So what we're going to do is you basically imagine, now you could do this at home with a pencil or a ruler or just using your imagination. If I move this vertical line across my graph, is it touching the function, this curvy line? Is it touching the function at more than one place at any time? And in this case, the answer is no. And you might start to think, well, over here it's getting close, but still, it doesn't exactly. Right there, there's the one place that it's touching. And if we slide over a little bit, well, right there is the one place that it's touching. If we slide over someplace different, maybe way over here, then right there is the one place it's touching. So because this graph, this function, or the vertical line is only touching the function at one place at any time, this is a function. So is this a function? Yes, because it passes the vertical line test. And you might be thinking, okay, well, what doesn't pass the vertical line test? So let's imagine this function right here. Instead of going up and continuing this direction, it like curves back around like this. Well, now your vertical line test, it would fail because it would touch the function right here and right there. It would touch the functions twice. It would go through this function twice. 1, 2, fail. 1, 2, fail. 1, it's passing over here. It's a function over here. But as soon as you get to there, 1, 2, now it fails the vertical line test, and it's not a function. And this is another way of saying this input thing. With each input has one output. The right there, right where the vertical line is, this, I'll move it just a tad. Right there. So I'm moving it when the x value is -1. Right there, your x value is -1. Your y value is like 1.2, I don't know, whatever that is, 1.2 roughly. But also, at -1, there's a y value of 2.8. So this same input had two different outputs. Does not work. Okay? So let's go back to how it should look. Get rid of some of this extra stuff. And the way the problem is shown right now, yes, this is a function. Letter C. Now we just have the same information except as a list of points. So if this list is confusing to you, I know some students who find it very confusing. What you can do is you can turn this into an input-output table. So you just go X, Y, whoomp, whoomp. So first point is 1, 5. And then 4, 3. 2, 6. 4, 2. This is probably much nicer and prettier to look at. Okay, now I don't care if you use the list as it's shown up here, or if you use the table that I have made, and you can make it as well. You're trying to determine if it's a function. So does each input have exactly one output? Well, 1 only goes to 5, 4 goes to 3, but 4 is also going to 2. That's not a function. This is not a function because if you imagine graphing this, 1, 2, 1, 2, 3, 4, you'd have a dot at 2, the y value is 2, but you'd also have a dot when the y value is 3. It doesn't pass the vertical line test. Each input does not have exactly one output. It has 2 different outputs. This is not a function. All right. Letter D. Same deal. So in letter D, we're looking through the inputs and the outputs to see if each input has exactly one output. So 5 goes to 1. Ooh, 5 goes to 4. That's 2 different outputs. So this guy would also not be a function because each input can only have one output. So, not a function. Kind of getting the hang of it? I think the next couple problems are for you to try. Oh no, I got a couple more here. Letter E. So in letter E, let's say here. So this may be confusing for some, so just make it into an XY table. It's probably quite a bit easier to understand. So 3, 6, -2, -1, -1, 4, 6, 4. Okay, 3 goes to 6. So 3 goes to 6, that's good. -2 goes to -1, that's good. -1 goes to 4, that's good. And 6 goes to 4, that's good. See, it doesn't matter right here that they both have the same output. As long as it's 2 different inputs, you're fine. What you do not want is one input, one x value, having 2 different y values, 2 different outputs. So this guy is a function. Yes, it's a function. Okay, letter F. Let's see, where's my, give me a vertical line here. We'll thin this up a little bit. There we go. And so as you're using your vertical line, you have to imagine all the points on the graph. So right there, it's failing. It's touching at 1, 2 points. Move it over. Fail, 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 fail. This graph, this is not a function. This relation is touching the vertical line at 2 different points, which means for each input, there are 2 different outputs. This relation is not a function, but it is a graph. But the question is it a function? And the answer is no. No, not a function. Ooh, this is not a function. All right. Now, here's something for you to try. So you'll see letter G here and letter H there. On your letter G, you'll probably need to plot these points. And your letter H, fill in your table the way I have it. Pause the video. Try these 2 problems. Figure out if these 2 are functions or not. When you're ready to continue, hit play, and we'll go through it together. All right. So hopefully you're done, and you made your decisions, your guesses on whether these are functions or not. So letter G, we have a graph. Even though this is only just a set of points and as opposed to a line, we can still use the same vertical line test. Let's see. Is my vertical line touching more than 1 point? No. Touching more than 1 point? No. You might be thinking, well, what about all this empty space in here? Doesn't matter. The only thing that matters is if your vertical line touches more than 1 point at any time, that would not be a function. But because this is only touching 1 point at a time, this is a function. Is this a function? Yes, it is a function. All right, letter H. So you have your table filled in, you check. does each input have exactly one output? -1 is going to 6. That's the only thing -1 goes to. Okay, 5 goes to 6. That's the only thing 5 goes to. 4 goes to 6, and 4 is not going to anything else. -4 goes to 6. 7 goes to 6. So each of these inputs had only one output. Yeah, it was the same output, but that's okay. If you would imagine graphing this, and I can't quite fit on that space there, but the graph of this would just be a horizontal line like this. If you go 1, 2, 3, 4, 5, 6, this horizontal line that I have here would be almost essentially what this function is showing. They're all going through -6, so if you use your vertical line test, it's fine. They all go through -6, but no point is the relation crossing this vertical line twice. This is a function. Each input has exactly one output. Yes, it is a function. All right, I think we have one more for you to try. So again, pause the video. This shouldn't take too terribly long. When you're ready to continue, hit play, and we'll go through it together. All right, so I can tell by looking at this that this is not a function. Now, I'm looking at this just the way you are right now, where this is just a list of points, but I can see 3 is going to 4, 3 is going to -2, 3 is going to 8, and 3 is going to 1. So each input does not have exactly one output. If we represent this as a table, so x, y, 3, 4, 3, -2, 3, 8, 3, 1, again, each input does not have exactly one output. This 3 goes to 4, and -2, and 8, and 1. So imagine that soda machine. Imagine there's a soda machine and you only get one button, because in this case we only have one input, just 3. And every time you hit that button, you get some mystery soda. You get a Coke, and you get a Sprite, and you get a Dr. Pepper, and you get a Mountain Dew, and you're confused because you shouldn't be. You should only get the exact same thing each time. So this soda machine would not be considered a working machine if you're getting a different soda each time you're hitting the same button. So this is not a function. Okay. So now we have an idea of what a function is. A function is just a relation that somehow goes from an input to an output. A relation is considered a function if each input has exactly one output, and as a graph that shows up by passing this vertical line test. We know that each relation has these inputs and outputs. I'm trying to go through the vocabulary that might have been confusing earlier. Inputs, outputs, functions, vertical line test. We got them all. All right. So let's see an application of this. It says here, Ralph calls a plumber to fix a leaky pipe. The plumber charges $30 to make house calls. He also charges $3 for each hour he works. The equation y equals 3x plus 30 represents the situation where x is the number of hours worked and y is the total cost in dollars. We want to determine if that relation, this y equals 3x plus 30, is a function. Well, we could do this a couple ways. Now, seeing as how we've already finished Module 4, we know that this equation is an equation in slope-intercept form, y equals mx plus b. And being in slope-intercept form, you know that this is a line. And you could probably, hopefully, pretty easily graph this line. So this line goes through the y-intercept of 30. So If you go up 30 spaces, we'll imagine that's 30 right there. So it crosses the y-intercept at 30, and it has a slope of 3. So go 1, 2, 3, over 1, 1, 2, 3, over 1, 1, 2, 3, over 1, and we'd get a linear graph, a straight line, looks something like that. Mine's not very straight, but you get the idea. Now this line would continue straight in both directions forever. So then we'll ask you, is this a function? Well, we now have a graph, and our graph should, I hope, pass this vertical line test. So here's our vertical line. Let's see. Yep. See, 1 point, 1 point there, 1 point there, 1 point there. Yes, this graph passes the vertical line test. Can I change color to that? Red. Nice. So the graph here in red passes the vertical line test. So that's one way to prove it's a function. We could come up with a table of values, an XY table, and go, okay, X, Y, you got your inputs and your outputs, and you plug in numbers like, well, when X is 0, Y is 30, and when X is 1, Y is 33. And you're going to find that for every value you plug in for X, you're only going to get one output. But this way is a bit less complete because you can't pick every single point. The graph shows more information, better information, as far as determining if something is a function or not. With only picking, say 4 points, maybe go -1, which would be 27, and -2, which would be 24. Okay, well, out of these 4 points, it's not a function. It shows that it is a function. But I definitely like the idea of graphing it better, because in a graph like this, you can see all the points, not just this one and this one and that one and that one. You can see all the points, and yes, this is a function. All right. Letter B. Arnold recorded the minutes he typed and the number of words he typed in that amount of time. The inputs are the minutes Arnold typed, and the outputs are the words he typed. Is the relation represented by his table a function? Okay, so we have a table here, and we have how many minutes he typed, 35 minutes, 25 minutes, 23 minutes, 46, and 50, all right, and the amount of words he typed in that time. So in 35 minutes, he typed that many words. In 46 minutes, he typed that many words. In 50, he typed that many. All right. So just based off the information we're given, we're supposed to figure out if this is a function. Okay, well, the inputs, the X values, will always be the first part of the whatever table we're given. So since this table is top and bottom, the first one, being the top, are the X. The bottom would be the Y. And it also says the inputs are the minutes he typed, inputs, X, and the outputs are the number of words he typed, outputs. So if this table is a function, then each input has exactly one output. So let's see, 35 goes to 515. Does 35 go to anything else? No. We're good. So check. 25 goes to 232. Does 25 go to any other number? No. 23 only goes to 299. 46 only goes to 489. And 50 only goes to 788. Check, 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 check. This is a function. It's a function because each input has exactly one output. It only goes to one other number. Yes, this is a function. All right. So here's one for you to try. It says Lisa has the graph below. Which 2 points can be removed to make the graph below a function? So you want to remove 2 points and make this a function. And then it says, why did you choose the points you did? Go ahead, pause the video, really to examine which 2 points would you remove and make this a function. When you're ready to continue, hit play, and we'll go through it together. Okay, well, since we're talking about a graph, we would be using this vertical line test. So there's my vertical line. A little bit longer. There we go. So I just check to see where does it fail. So it's passing, passing. There's nothing in between here, so don't worry about it. Ooh, fail. So one of these 2 points needs to be removed. If you remove one of them, then it would pass the vertical line test right there. So let's just play pretend. Oh, what am I doing? Marker. Let's just play pretend that this guy is now gone. Ooh, how about this? Can I color in white? Ooh, sweet. There you go. He's gone. Alright, so now, yay, passes the vertical line test. Okay, keep going, keep going, keep going, keep going. Oop, failure. It doesn't work because right there, it has 2 points on the same vertical line. That is not a function. So, either this guy or that guy. I'm going to pick the top one just because. There we go. Now, each point passes this vertical line test. A second ago, give more information. If I erase this guy, if you were thinking weirdly and you were using a horizontal line, you might go, oh, those 2 points are in line and those 2 points are in line. Doesn't matter. It's not the horizontal line test. It's the vertical. This, even though these 2 points are on the same line, it is still a function. It's only not a function if it doesn't pass the vertical line test, like this. Alright, let me go back in and scribble him out. Alright, so it says, why did you choose the points you did? So the points that we chose because each input had, at that point, the input had 2 different outputs. The points I chose, CH, were because at that point, the input had 2 different outputs. It did not pass the vertical line test. There, I think that's a decent answer. So it says the points I chose were because at that point the input had 2 different outputs. It did not pass a vertical line test. That first sentence doesn't make sense, but that's okay. The points I chose there we go. Some movie magic just happened. So I edited my response. I like this better. So the points I chose were when x equals 2 and when x equals -2, because at those points the input had 2 different outputs. It did not pass the vertical line test. There we go. I'm not going to accept substandard work, neither should you. So now I like my sentence, and that's the reason why those points did not work. Alright, letter D. Here's one for you to try. It says take the relation shown below and write that relation as a table and also as a graph. Identify if the relation, table, and graph are functions. Be sure to explain your reasoning for each. So in case you're unclear, you're going to take this data. You're going to put it in your table. You're going to make a graph of the same data. And then you're going to determine based off of the table and based off the graph if this is a function, and you're going to explain why for each of them. So if it's not a function here, you're going to explain why based off the table. If it's not a function in the graph, you're going to explain why based on the graph. Okay? So go ahead and pause the video. When you're ready to continue, hit play, and we'll go through it together. Alright, so let's see. So we're going to take our data. So input of 3, output of 4, 2, 1, -3, 4, 2, -3. Okay, so let's see. Based on just this, is this a function? Let's see. 3 goes to 4. 2 goes to 1. So 2's going to 1, but 2's also going to -3. So at that point right there, this input has two different outputs. So based off the table, I'd say this is not a function. Because the input input x equals 2 has two different outputs. Y equals 1 and y equals -3. All right. So just based off of the table, it's not a function because this input has two different outputs. Okay, so about based off the graph. 1, 2, 3, 1, 2, 3, 4, 2, 1, -3, 1, 2, 3, 1, 2, 3, 4, 1, 2, -1, -2, -3. All right, so based off the graph, now we'd have to determine if this is a function. I'm getting myself a little vertical line going on here. There he is. So it passes here, it fails here, passes there. So it's not a function because of right there. So not a function because it fails the vertical line test. This is not a function because it fails the vertical line test at an x value of 2. And it's not a coincidence, it's the same place that we failed over here because this input had two different outputs. Right here, it failed at that same input, that same x equals 2. That's not a coincidence. That shows that at that point, that's what makes this relation not a function. All right, I think we answered the question, right? Identify if the relation, table, and graph are functions. Be sure to explain the reasoning for each. Well, I guess the reasoning for, if we looked at this relation here, we'd use the same reasoning as we did down here. It's not a function because the input x equals 2 has two different outputs. Right here, x equals 2 has two different outputs. Therefore, this would not be a function for the same reasoning that we put for the table here. All right, summary. So in your own words, describe how you can tell if a relation is a function. Go ahead, pause the video, and see if you can get that in there. How can you tell if a relation is a function? All right, so I put down my response. I say here, if you're looking at a graph, then use the vertical line test. If the line only touches the relation at one point, then the relation is a function. If you're looking at a table or a set of points, check to see if each input has exactly one output. If each input has exactly one output, then the relation is a function. Lowercase, nice. So, this lesson has been about what is a function and what is not a function. It's been lesson 5.1. Thank you for watching.